Okay, so we are starting the focus activities for the second 6 weeks a little early, and that's okay. Next week you'll get number 2, and we'll see how far we can get. We'll turn those in probably in 2 or 3 weeks. I'll let you know ahead of time. Remember, we already turned in 4, 5, and 6 yesterday. If you were absent and haven't turned those in, please go ahead and do so. If you were here and didn't turn them in, don't worry about it. Okay, it's gonna bring down your grade a little bit, but come talk to me. We're probably not gonna be able to do anything about it. But tomorrow, what are we doing? District assessment. Okay, that's how we're going to end the 6 weeks. This is going to give you bonus points on your test if you do what? If you score 60 or above. So you only got to get 12 questions right. And the 2 classes today, I'm going to go ahead and get you started probably about the last 10, 15 minutes because we do have to have this done tomorrow. So I'm going to get you started today to hopefully ensure that happens. They're saying that the test so far is pretty straightforward, pretty easy. So I'm hoping you guys will find it to be just the same. So let's see. One other thing, because tomorrow is the last day of the 6 weeks, by 8:05 tomorrow morning, what is that deadline? For the retake on the exam. Now, I've been having a lot of people come in to do that, and if you've come in, thank you very much. I will be here the one last morning if you need to come in, but by 8:05, that's going to be the end of it. So during the afternoon and the morning, you're not going to have that opportunity. So come on in and talk to me if you need anything in particular. Okay. Well, let's see what we got here. We were talking about inverses yesterday, and how far did we get on this problem? Did we get it completed? Okay, so we did. We started with 2 minus x squared, and we noticed that that graph was not 1-to-1. What does that mean? Okay, that's telling me that the inverse won't be a function. Now remember, when you applied the vertical line test, that visually tells you if any values of x repeats. Okay, well the horizontal line test is visually showing you if any values of y repeat. If no values of y repeat, it is 1-to-1. That guarantees us the inverse is going to be a function. If there are values of y that repeat, remember when we take the inverse, we swap the x's and the y's. So those repeating y's suddenly become what? The repeating x's. So what we were looking at on this problem was if our original graph is not 1-to-1, we wanted to go ahead and restrict him to make sure that he was and ensure that the inverse was going to be a function. Not like on the earlier problem in the notes where we had to leave it as a relation. In fact, that was B, I want to say. So we restricted this guy from 0 to infinity. Okay, and his range was -infinity to 2. Remember, we only took half of that downward opening parabola, the right half. But we talked yesterday, does it really matter how you restrict it? Okay, actually it doesn't. I tend to lean more towards the positive side. That's why I said 0 to infinity. But had I chosen to go ahead and restrict it on the left side and not have the right, the domain would be -infinity to 0. And there would have been one change in my function here. Because think about how this graph would look. If I were to take the left side in red and I reflected him, think about what you see in the graph. What's the one change that would need to happen in the square root of 2 minus x to get that guy? Connor says you'd have to have a negative in front. Yes, because the x is negative. See, it reflected it backwards across the y. But with a negative in front, that also gives it a second reflection, so it completes what we need. Okay, so where you restrict it, you do want to be very mindful about the inverse that you're coming up with. Okay, so let me go ahead and take those off. Okay, well, here, let me go ahead and write this down again. Again, you have it on your paper, but it's just ideas that I really want to hammer in. For the inverse, the domain will be what from the original? Will be the range. So it should be -infinity to 2 included. And the range of the inverse should be, save it? There you go. The domain of the original. Remember, because we're just switching the x's and the y's. So 0 to infinity. And if you go ahead and take a look at this graph that curves up to the left, it does go from negative infinity to 2, and it does go the range. Oh, wait a minute. What am I trying? I totally wrote that wrong, didn't I? No, wait. No, I'm right. Okay. Sometimes I even second guess myself. No, we're good. Okay. So is everybody caught up on what we've been doing for inverses? All right. Well, there was only one last thing to do on this problem, and I don't know if we talked about it, if we got that far. What do I still have to do? Ooh, who said it? Okay, we got to take the composition of the two functions, because I want to show algebraically that, yeah, they're going to be inverses of each other. Now, what this means is I want to take, or I believe this is G, right? Is it G? No, this is F. It's the next problem, this G. Okay. So F of F inverse of X should give me X, and F inverse of F of X should give me X as well. I want to show the composition both ways is going to give me X. And remember, X isn't random. That's really important to us when we're talking about inverses. That's my line of what? Okay, let's take a look at our graph here. That's my line of symmetry. Any graph that I reflect across that line of symmetry, y equals x, is going to be the inverse. Okay. You remember I showed you the other day if I took a piece of paper, the top left corner, and I pulled it down to the bottom right? Okay, that little trick, that is reflecting across the diagonal there. Okay, so with this, we're not inputting a value. I want to actually go ahead and plug the entire function into the other. Okay, so let's take a look at f of f inverse. So I'm going to take this guy right here, the square root of 2 minus x, and I'm going to plug it into the original function f that we got. So that was 2 minus x squared, correct? So I'm going to say 2 minus, well, instead of x squared, I'm going to go ahead and plug in the square root of 2 minus x, and then squared. Okay. Now, what's a square and a square root going to do to each other? Yeah, they're going to cancel, right? Okay, so I know those guys are going to cancel, but I still have to distribute the negative across what's left. So while I'm going to get 2 minus 2, I am going to get what? Plus x. And you'll notice those 2's cancel. There we go. Now, it has to be x exactly. If there's any variation on that, even something as small as a negative, I can't say that they're going to be inverses of each other. It has to be x. No exceptions on that. Okay, so that takes care of that one. So is that enough to show that they're inverses? Yeah, remember, I got to do it both ways. Is it possible to work one direction but not the other? Absolutely. Okay, so it's always a good idea to check that. So now, why don't we go ahead and plug f into f inverse. So remember, f inverse, we got the square root of 2 minus x, right? So I'm going to replace x with the 2 minus x squared. So I have the square root of 2 minus x squared. Okay. Now let's distribute that negative. So what's my radicand become? 2 minus what? Minus 2 plus x squared. Okay, so again we see that the 2's cancel. The square root of x squared will give me x. Now I'm just kind of throwing this out there to see who remembers it, because I am big on being able to spiral in material whenever I can. Does anybody know technically what should I be putting around that x for this one? This refers back to your exponent rules when you were simplifying radicals. Okay, Aiden's over there. She's making this motion with her fingers. I'm guessing absolute value. That is absolutely correct. Do you guys remember when you simplified radical expressions, occasionally some of those terms had the absolute value around them? Do you remember how you were able to know if that was the case? What kind of index did you need? Okay, I'm sorry? Well, positive, sure, but even. It had to be an even power. And then what kind of power did I have to get when I divided them? Odd. Okay, because here's the thing, we don't know what x is. X could be 0, x could be positive, or x could be negative. And if we want to guarantee that we're going to get, in this case, the positive result, well, that's where the absolute value would come in. And this has nothing to do with the inverses. I'm just kind of throwing that out there to see. How many people does that sound familiar to? So some yes, some no? Okay, all right. But the important thing is we got our x, and we know their inverses. Okay, so we're good to go. All right. So now remember, just like when maybe you're going to be looking at a quiz or a test or even a district assessment very soon, hint, hint, okay, you only have to restrict the domain if the original graph, what? Is not one-to-one, because we want to guarantee that the inverse is a function. If it is one-to-one, you got no worries, just proceed with the problem, okay? So speaking of, let's take a look at 4b. This is our last example. Okay, we got function g, which is the cube root of x plus 2 minus 1. Okay, so what does the cube root parent look like? Okay, like what? Do it again, Christian. Like that. Okay, so it looks like almost like an elongated S, right? Okay, good, good, good. So let me go ahead and draw the parent, and let me see how well I can do this, because the other two classes have been just a masterpiece. Maybe something like that. Okay. So it definitely goes through the origin. The cube root of x would go through the point 1, 1. It would go through the point -1, -1. Okay. But this isn't the parent. How has he been transformed?
That way by 2.
Okay, so he's moved 2 to the left and 1 down? Now I always get confused about this. Why left? It says +2.
Well,
true, but when you... Okay, it's when you affect x directly. If you're adding or subtracting, you take the what? The starts with an O. The opposite. Now, if I were multiplying by x for a horizontal dilation, we take the reciprocal, okay, and that is your true scale factor. So I will do this with the mouse because it has not been working too well if I try it with my finger. So I'm going to go ahead and take this point right here at 0, 0. Now, if I moved everything 2 left and 1 down, this point at 0, 0 should end up at -2, -1, right? Okay. So like I said, it's not going to be perfect, but we have a pretty good idea of what the sketch looks like. And you also have your technology to kind of help you out with this. Okay. But now here's what's really important. Let's get to it. If I put a vertical line through this guy, is he a function? Yes. There is no place on this graph where I would touch him 2 or more places, so no values of x repeat. Okay, he is a function. Okay, now here's the more important question. Kyle, is he one-to-one? If I put a horizontal line through this guy and started moving him vertically, would I ever hit the graph in 2 or more places? Okay, he says no, so it is one-to-one. Yes. Why is that good news for us? There you go. That not only means that our inverse is going to be a function, but it means we do not have to worry about any domain restrictions. Okay, we don't have to change a thing. We move right on with the problem. Okay. So let's see, Rhett, how would I find that inverse? How have we been doing it since yesterday and last week? Okay, he says you switch the x and the y. Okay, so g of x is y. So x is equal to the cubed root of y plus 2 minus 1. Okay. Now, once you switch the positions of x and y, you solve for y, you're good to go. So walk me through this. What would I do? Add 1. So x plus 1 is equal to the cubed root of y plus 2. Okay. Now we want to go ahead and get rid of the cube. So because I have a binomial on the other side, I want to cube the quantity. So x plus 1 cubed is equal to the cubed root of y plus 2. I'm going to cube that as well. And again, what's a cube and a cube root going to do to each other? Cancel, yeah, because they're inverses. So what is my last step? Okay, so x plus 1 cubed minus 2 is equal to y. Now remember, this is something we talked about yesterday, something I'm hoping you're going to remember today. Do I leave it like that, or do I change something? What am I referring to? Okay, Stephanie? There you go. We know this guy is an inverse, so I can replace y now with its notation. That's my last step. And you remember that problem B, I think it was 1B, way back at the beginning of the lesson, he was not a function, so we had to leave it as y. We just called it an inverse relation. Okay. Good, good, good. And if I were to go ahead and graph it, let's take a point. We already talked about this point right here, -2, -1. That would be on G. What would that point look like if he was on the inverse? -1, -2. Remember, you do not change the signs, the values themselves. You simply reverse them. So I know this G inverse has to go through -1, 2. And let me see if I can make this look somewhat decent. Okay. So does that look like the cube parent moved left 1, down 2? Yeah. Okay. Maybe you got to squint, tilt your head a little bit because it's not perfect. But this is where you say, "Oh, Mr. West, that graph is awesome." Hey, thank you, sir. Thank you so much. I appreciate that, Dylan. All right, questions. Okay, but there's still something I want to do. Remember, what did we do for the last part of the previous problem? The composition. Okay, we want to go ahead and show that, yes, they are inverses of each other. Okay, so I'm using function g now. So I want to be able to show that g of g inverse of x is equal to x. And I want to show that g inverse of g of x is equal to x. Okay, so just like we did before, I'm not plugging in a value, I'm plugging in a function. All right, so let's plug this inverse into the original first. So see, here we have the cube root of x plus 2 and then minus 1. So this x, I'm just going to replace him with that inverse that we found. So this is going to be the cube root of, I'm going to have x plus 1 cubed. Then we're going to have minus 2. Now that right there is simply x. We still have that plus 2. And what else am I forgetting? The minus 1 outside. Is everybody okay with what I did? Okay. Just like we practiced earlier in the week, last week. Okay. Well, what's the first thing you notice? 2's cancel. They're out. So I'm taking the cubed root of a cubed quantity. So what happens there? Okay, the cube root and the cube are going to cancel. Now that leaves me x plus 1, and what am I forgetting? We still have that minus 1 on the outside. So when those cancel, the composition does simplify to x. Right, Xavier? Right, head up please. Okay. All right. So it looks like we got x. I say we're good to go. I can just go ahead and stop the problem and we can move on. Okay, well, I'm waiting for some folks to say, no, stop, wait, okay. So why are you folks telling me that? Okay, Dylan's right. Now we have to show it the other way. We showed it g of g inverse. Now I have to be able to plug the original into the inverse I found. Okay, so let's see here. The inverse we found, okay, let me go ahead and do this. It was the x plus 1 cubed minus 2. So I want to plug the original function in for x. So that whole guy's going in. Okay, so for this guy, we're going to have the cube root of x plus 2 minus 1. Now that's just the x. Then I have the plus 1 cubed minus 2. Okay. Now it's okay. It's really easy to get turned around on those sometimes. I absolutely did in first period. Took me a second to figure out what I was doing. But we ultimately got it. Okay, so what do you notice is going to happen? The 1's cancel, so they're out. Now I've got a cube and a cube root, which are inverses of each other. So I'm left with x plus 2, minus 2 on the outside. Those cancel. There we go. So the composition confirms to me both ways these guys are inverses of each other. Okay. How we doing? Okay. All right. So we actually have a little more time than we did in the previous classes, but I think that's okay. Hey, I do need to go ahead and tell you guys, I got kind of relaxed on doing this, and that's totally my fault. But second period got a little annoyed with me because I'm starting to do this. If I go ahead and ask you to put the calculators up before the bell rings, we need to go ahead and get that done quickly because I do need to start checking to make sure they are here before you guys leave. And I really haven't been doing that. Like I said, that's my fault. So we need to get back in the habit of doing that. Also, what are we selling those chocolates for? Is there anybody in here doing that? Zach, you're selling the chocolates, right? Okay, but what's it benefiting?
For right now, it's Carlos' dance.
So it's for dance. So something important. Good, okay. But, and I'm not saying it's you personal. I really want to go ahead and say, encourage you guys to continue selling those. I want you guys to be able to eat them. But I am finding a lot of wrappers on my floor. And I'm not, again, saying it's you guys. I'm just going to be telling this to all the classes. Okay, so like we talked about at the beginning, I'm not going to let you leave until I see all those calculators, until I see the floor is clean. So the faster we get that done, the faster I can get you guys out of here. Okay? If it's not done, it's that much later, you're going to be going to your class. Okay? So work with me on this. We're good? I got one yes. All right. Awesome. Awesome.